what is a radian? A lot of people can tell you how to go from degrees to radians and from radians to degrees, but not many people can actually tell you what a radian is. You can define radians as the ratio of arc length to the length of the radius of a circle. To get a picture of that, imagine that we take this radius and stretch that length out along the circle, along the circumference of the circle. So what we're saying is that the red length is equal to the length of the radius. If the radius is 5 centimeters, then this red arc length would also be 5 centimeters. The measure of this angle that we see would be 1 radian. So how many radians are there in an entire circle? To think about that, start by thinking of the formula for circumference. The arc length that corresponds to 1 radian is equal to the length of 1 radius. So we need 2 pi radians to go all the way around our circle. Two pi is pretty close to 6.28. So we're going to need 6.28 radians to go all the way around. It might look something like this. 1, 2, 3, 4, 5, 6, with a little bit left over. That would be our 0.28. Let's connect this to degrees. We know that a circle has 360 degrees. And now we know that it also has 2 pi radians. So 2 pi radians is the same thing as 360 degrees. You can think about this proportionally. 360 degrees is the same thing as 2 pi radians. So what would 180 degrees be? Pi radians. What about 90 degrees? Pi over 2. Let's figure out what 1 radian would be equal to. If we cross multiply and divide, we're going to end up with 360 divided by 2 pi is equal to 1 radian. Or 180 degrees divided by pi would be 1 radian. How much is that anyway? If you divide it out, you'll find it's pretty close to 57.3 degrees. So 1 radian is approximately 57.3 degrees, almost 60 degrees. So when would we use radians? One practical application is when we're trying to describe arc length. There's basically 2 ways that most people calculate the length of an arc in a circle. One is to use proportional relationships, and the other is to use Radian Measure, and that's the one that is going to be new this year. Let's compare those 2 methods. Let's say that we're trying to find the length of the arc shown below in red. The arc has a measure of 90 degrees, and the radius of the circle is 20 centimeters. One way to find the arc length is to write a proportion. 90 degrees over a total of 360 degrees in a circle is going to be equal to x over the entire circumference of the circle, which is 2 pi r. When we substitute 20 for r, we can solve our proportion. Let's simplify this a little bit. So x will equal 10 pi. That's how we would solve this using proportions. We can also solve it using Radian Measure. Here's a new formula to add to your toolbox. The radian measure is equal to the arc length over the radius. We can solve that for arc length pretty easily by multiplying both sides by the radius. In other words, the arc length will equal the radian measure times the length of the radius. Here's the shorthand for the formula. S represents arc length, theta represents the radian measure, and r represents the radius. S equals theta r. To use our formula for this problem, we first need to change 90 degrees into radians. We actually already did this earlier. It looks pretty familiar, doesn't it? Earlier we found that 90 degrees was equal to pi over 2 radians. So let's substitute pi over 2 into our formula. Theta will be pi over 2, that's our radian measure, and 20 will be r, that's our radius. Let's simplify this a little bit. 20 times pi over 2 is going to be 10 pi. The same answer as before. Let's do one more example like that. This time we're trying to find the length of an arc that has a measure of 60 degrees and a circle that has a diameter of 10 inches. Using proportions, we would write 60 over a total of 360 degrees is equal to x over 2 pi r, substituting the length of our radius for r. How long is the radius in that circle? 5. 10 is the diameter, so the radius is 5. 6 over 360 simplifies to 1 over 6, and 2 times 5 pi gives us 10 pi. When we cross multiply and divide, we end up with 10 pi over 6, which simplifies to 5 pi over 3. So we have an arc length here of 5 pi over 3 inches. Let's do it using our formula for arc length. Remember, it's arc length equals the radians times the radius. So we need to know how many radians are equal to 60 degrees. Remember that 360 degrees equals 2 pi radians. We want 60 degrees. So how many radians would that be? We can cross multiply and divide here too. We'll end up with 120 pi over 360, or pi over 3 radians. Let's substitute that into our formula. So our arc length will equal pi over 3 times the length of our radius, which is 5. And that's going to give us 5 pi over 3. Same answer. So radians give us another way to talk about arc length. We can use proportions, or we can use the definition of a radian. Both will give you the same result. Both of the options we've looked at are great ways to talk about arc length. Here's an example of when it would actually be easier to use the definition of arc length as the product of radian measure times radius length. Let's say that we know that we have an arc length of 12 feet and a radius measure of 3 feet, and we want to know the measure of the angle. In this case, our new formula is going to save us a lot of time. Check it out. Just substitute 12 for your arc length. We'll leave the radian measure there. We don't know that yet, is our unknown. And then our radius is 3 feet. Can you see now how many radians we're talking about? 3 times 4 is 12. So the radian measure of our angle is 4. See if you can figure this example out on your own. Once again, we're looking for the radian measure of this angle. We know the arc length is 46 meters and the length of the radius is 20 meters. Pause the video and give it a try. Arc length equals radian measure times the length of the radius. Let's substitute. 46 equals the radian measure times 20. So we just need to do 46 divided by 20. 46 divided by 20 is 2.3. So our radian measure is 2.3.